Raise your hand if you have a question. Way in the back. Yes, that's you. Waving to me.
In the reader on page 80.
Is this the lecture notes or the practice exam?
Lecture notes.
Lecture notes, what page?
Page 80.
80. Just a second, let me find it. Okay, I'm ready.
Could you go over that example?
The example you see on page 80 of the lecture notes, you won't have to know for the exam. So if Rachel didn't state that clearly, this is finding the finite values of R at a node, and we no longer teach that, but sometimes it's on homework questions, so that's why it's still existent in the reader, but you would not find this on a practice exam. A really old one, but I think I've removed all the old practice exams. Cool. That answer your question pretty much?
Yeah.
Okay. Yes?
Can you go over all like the SI units that
I missed that last part. Can I go over
the SI units you need to know for the conversion integration?
the SI units that you would need to do a calculation?
Yeah.
Okay.
So, like the convert, like you give us a multiple choice.
Oh, like in the multiple choice where we convert, we simplify something? Okay. Should I just pick a random multiple choice problem?
Yeah, that would work.
Okay. It's pretty common. So I'll find a problem and then I'll say a couple general concepts before we do the calculation. So exam 2, I have been on the vibe of putting a multiple choice calculation question, not calculation, multiple choice units question on every single exam. Lately, I've liked putting it as number 1. So almost every, this is fall 16, I didn't think of that idea yet. But I've been doing this kind of question pretty much on every exam after I thought of it. Okay? So let's try this one. I'm going to recopy it, but this is Winter 16, page 60. So the question is, it has this. It's simplify. And then I always have the same answers as the Pascal, Newton, kilogram, whatever. Okay? So the answers are the same. Question differs every time. What do you need to know to do this problem? You need to know that a Pascal is a Newton per meter squared. You need to know that a Joule is a Newton meter. You need to know that a Newton is a kilogram meter per second squared. If you don't know those, you have no hope. Okay? So I would, if I was afraid of forgetting this on the exam, I would write this and whatever else I'm afraid of forgetting, like the L values and how they connect to the letters, on the back page of the exam, so you can refer to it later when you've blanked out. Okay? So, let's simplify this a little bit and just see what happens. So, we've got a kilogram. On the top, a meter squared, meter times meter. On the bottom, we have a meters cubed and a second squared. Alright, well, I noticed some meters cancel. This ends up being a kilogram meter second squared. So like, cool, what the heck is that? It's simplified. Well, then you might have to compare with some of these. So, for example, it's not this one. You see? It's this one divided by what? This is this divided by meter squared, which is also a Pascal. So if you weren't sure, if you didn't notice that, hypothetically, then you would say, okay, let's go through these randomly. I wonder what a Newton per meter squared is. Well, that's a kilogram meters per second squared divided by a meter squared. Cancel out one of the meters, that's a kilograms per meter second squared. Oh, hey, they're the same. This must be a Pascal. So you have to do that kind of manipulation. Is that okay? A classic. Make sure you practice it. Okay, who's next? Yes? Fall 12. Hold up. What page? 88. Number 2. Okay, so this is fall 1288. I'm gonna copy that one down. It's just like that question. Newton, Joule, Pascal, to the 1/3 power. Same thing, I've got to use these 3 unit kind of conversions. Okay, well, Joule, we got Newton. Joule is a Newton meter. A Pascal is a Newton per meter squared. And this is the 1/3 power. All right. It looks like, to me, the newtons drop. And I've got a 1 over meter squared, which would end up being a meters cubed. A newton, meters cubed to the 1/3. That'll be a Newton meter. That is, if you don't recognize it, it's a joule. Wow, I know, it's awesome. Aren't these problems awesome? Okay, is that cool? Okay, next, in blue with the hat.
Oh, are we going to need to know by name Boyle's law and all that, or do you just need to know like how things multiply? Like,
do you need to know Boyle's law, Charles' law by name? No, not necessarily. Just how to use them or how to pick the right equation.
Is there going to be like a vocabulary question like that?
I don't. Well, would it be vocabulary? It'd be more like a fill in the blank or something. I don't think I've ever done that. Maybe, and I forgot. But that's not my style usually. Yes. Okay, next, yes. Okay. Will there be a radii question? No, we haven't got there yet. So I'm sorry, you'll have to wait till the final. Okay, yes. What page? Oh gosh. Fall what? Okay, fall 2014. Hold up. Okay, yes, now I'm ready. Number 3. Okay? You have to calculate it. So, this is a velocity question. So you have to calculate the root mean square velocity. So, helium at 300. Let's do that one. You can do the other one yourself at home. Is that okay? So, the root mean square velocity of helium, 3R, 8.3145 joules per mole Kelvin, times the temperature, 300 Kelvin, over, yeah, that made no sense. Over, it's about 4.003 or 0.004003 kilograms per mole. You calculate this number, you calculate the other one, and you compare the two. So they're probably going to be about the same number, which is why C is the answer. Is that all right? Yes, you do the exact same thing for argon at its temperature. So for argon, there would be a different number here and here. Cool. Okay, who's next? Yes, in purple. Lavender, maybe. Ooh, I didn't bring that. I'll borrow yours. Yeah, what about it? Okay, week 6 worksheet, my discussion worksheet, number 1, calculate average kinetic energy. Okay, it looks like you kind of got it here. Oh, that's unfortunate. Okay. Let me show everybody here. It's okay, I have to show them your thing. Okay. You have nice handwriting, so it's okay. All right. And good highlighting skills. Okay. So, find the average kinetic energy. You've only got a temperature, right? So, I would use this is really the root mean square velocity, not the kinetic energy per se. So, I probably would have, I have to move this now, unfortunately. Let me set it up and hopefully you can solve it at home. Okay, so the root mean square velocity, sort of 3RT over M. Okay, in here, I would have put the 298, and the M, which would be the molar mass of oxygen, okay, in kilograms per mole. Find the root mean square velocity. Oh, wait a minute. Why don't you just do this? Now I'm rethinking it. 3 have RT. Why don't you put 298 in there? This is even easier. Even easier. Okay, you've got the kinetic energy, but this will be in joules per mole. You want it in joules per molecule. Okay? So then what do you have to do? Well, joules, let's see if we can convert this. You need to know how many moles per molecule you have. So it would be joules per molecule. How do you find that? Anybody? What's that? Yeah, I think so. This is just 6.022, right? Okay, boom. It's just a conversion after you use the kinetic energy formula. I'll let you solve it at home though. Okay, who's next? Okay, way back there.
For page 69, winter exam 2015.
Okay, hold up. Page 69 is what I'm flipping to right now. Okay, what number?
15.
15? This one right here?
Yeah.
We haven't done radius yet, so I'm sorry you have to wait for the final. Okay? Cool, that's the coming up section we haven't got to. All right, who's next? Yes? Happy to answer that for the final one. Okay, page 93. Is that what you said? Okay, what number? 12. Right here. Okay. Let's see. All right, this has 2 gases, and we see information about pressure, volume. I'm thinking Dalton's law, a mixture of 2 gases, whenever you have something like that. So if it's a mixture of 2 gases, it's Dalton's law. So you just basically have to do some math right now. So I'll try to set it up for you. Hopefully you can solve it at home. Okay. Is set up the main issue?
I just got the wrong answer.
That's unfortunate. Okay. So we've got 2 grams of helium. It's in a 10-liter vessel. Oops. So there's the volume. It's fixed. This also has oxygen in it. O2, looks like they're mixing together. This is at, they're all at the same temperature, 25 degrees C. The pressure, so the helium's added. This is initially at 740 millimeters of mercury. Okay, so we're adding, this is added into the container. This is, the oxygen's there initially. Okay, when you add the helium, and the 10 liters goes for the whole vessel. This is 10 liters. Okay, so the 2 grams of helium is added to this pre-existing container of oxygen. What would I do? With Dalton's law, I always do moles first. If you remember, you convert to moles. So, for helium, that's just going to be 2 grams, and then you use the molar mass from the periodic table to get the moles. This will be the moles of helium and helium. For the other one, though, we've got PV equals nRT, so you got to do it another way. For this one, you go moles is PV over RT. P 740, and then you've got to convert to atmosphere, so it would be the 1 atmosphere of 760 millimeters of mercury. V, 10 liters. R is R, and T is 25 plus 273. So that would be moles there. This would be the moles of oxygen. And so you can find the moles total if you needed it. That's the moles of oxygen plus the moles of helium. What do they want to know? What happens basically with the final pressure? So P, the final pressure, depends what which multiple choice you're kind of going for first. But if you go, most of them involve final pressure, it looks like. So that would be N total, which you just found, RT over V total. V total, remember that's 10 liters. Is that okay? The 25 doesn't change. Yeah, 273 to that. Is that kind of okay setup for you? Based on what you get, go from there. Okay, who's next? Yes, right here.
For electron configuration of an ion, what order do you take away the electrons?
What order do you remove the electrons when you have the electron configuration of an ion? Typically, if you look in the periodic table, you're just going to go in reverse order, typically. There's an exceptions to that, though. But let's say, for example, you had oxygen. Oxygen would be 1s2, 2s2, 2p4. So if it's oxygen minus 1, you add 1 to it. So it'd be 2p5, like fluorine. If it's oxygen plus 1, it'd be like nitrogen. So you eventually do it for nitrogen. So instead of 2p4, it'd be 2p3. So plus 1, you're just doing it for the element on the left. Minus 1, you're doing it for the element on the right. There's exceptions that involve the d orbitals, or transition metals, we haven't learned yet, so I'm sorry it cannot be on this exam, but I will cover it next time, because next time includes final exam material. Okay? So you'll see it on some practice tests, because it depends on the quarter and when the test is. We got the test a little earlier this time, so it doesn't include everything. Like everybody wants to know about radius. I'm sorry I have to put it off till later. Yeah, okay? Who's next? Oh, we're done. Sweet. Oh, okay. Last question, I guess. We're almost at 9:10. Or, yeah, I think that's when our regular completion goes to. Yeah. Fall 1288. Page 88, you said? Okay, hold up. Let me find it. It's always exciting to do chemistry problems on a late night. Okay, what number? 8. This one right here? Okay. You want it to be A, or you want it to be D? You want it to be A? I mean, that sounds cool. I don't know. To increase the volume of a fixed amount of gas, that means N is constant. The moles are constant. It looks like you're doubling the volume, 100 to 200. So the volume doubles. You think that this might cause the temperature of 25 to 50, but that's probably not going to happen. Let's look at D for a minute. You don't want it to be D, but it probably is. Is that right? It looks like, let's write down the little formula here. Let's see if I zoom out. Hopefully you can kind of read it and see this at the same time. Okay, PV equals nRT. The V is going up times 2. Okay? So to keep everything the same, because the temperature is not changing, R can't change, moles aren't changing, so the pressure, according to this, goes down by 2. That would work. So one goes by half, basically. I'll write half if that's easier to understand. And one doubles. That would work. You were excited, I'll write it on the top, by something that's incorrect, unfortunately. This going up times 2. This not changing, not changing, not changing. And the temperature, is the temperature doubling, everybody? Or going, is the temperature doubling? Yeah, that's my question. What do y'all think? It's going up, does it double? No, because it's in Celsius, and you need to change it to Kelvin. Right? So we're going from 298 to 323. That's not a double. If it did in fact double, that would be correct. So if it went from 298 to whatever is 2 times that, about 600, 696, yes, you would have been correct. But it's a wrong units. Okay. All right, let's stop there. Our room reservation is ending. I'll clean up. I know everybody wants to study chemistry more, but I'm sorry we can't. custodian will kick us out. So I'm gonna clean up, make my way out. I'll see most of you not tomorrow, but the next day, Tuesday morning. Have a nice rest of the long weekend. And I'll try my best to get that video online if there's no technical issues.